Hi, welcome again. This is problem set 1. We're talking about algebra word problems where you'll read the word problem and you'll have to set up some kind of equation or an idea here of how to solve the mixture. Now, this is the first problem set. As I said, we're going to finish this video series in a self-quiz. But the idea is, in this first problem I'm going to have you try, it's about unit price. And my example from the previous video, just a quick review here, is you're given one container added to another container. It equals some kind of a mixture, and what you have to do is two things. You have to figure out the cost of each container, therefore the cost of the total mixture, and then you have to figure out the amounts so that you know the amount in the final mixture. Now in these kinds of problems, usually one part of that is missing. Alright, and either you're given the mixture unit price or you have to figure that out. Okay, so it's the total cost divided by the total amount. So I want you to look at this problem, and I'm going to pause here to have you try number 2. So go ahead and read it, pause the video, give it a try on a piece of paper. It's actually pretty easy, but let's start with this one. Go ahead. Alright, number 2, 1 pound of peanuts, which costs $4 per pound, was combined with 2 pounds of spices, which costs $1 per pound. Find the cost per pound of the mixture. Alright, well, the cost of the peanuts is 1 pound at $4 per pound. So that's pretty easy. That's going to be a $4 cost. Alright, of the peanuts. Then we look at the 2 pounds of spices, which is $1 per pound. And 2 times 1, of course, would be $2. So we have a total cost of $6. All right, no problem there. Then the amounts, well, we have 1 pound plus the 2 pounds, 1 pound of peanuts, 2 pounds of spices equals 3 total pounds. All right, pretty easy, isn't it? So now we're going to divide the 6 by the 3, and that'll give us a mixture price of $2 per pound. All right, very simple example, but I want you to kind of get the idea here. We got to figure out the costs and the amounts and then divide when we're done. All right. All right, I want to introduce to you another type of mixture problem, which is fluids. All right, and the two I'm going to have you try in this video are examples of that. Now the idea is we have one container of a fluid, and we're going to add it to the second container of the fluid, and we're going to end up with a larger container of a mixture. All right. Now I just realized here that in my drawing I did this backwards. This is supposed to be oil, believe it or not, and now I realize, oh, oil is going to float. So actually I should have switched the two colors. So we'll have to use our imagination. Maybe we got some really heavy oil going on here. Sorry about that for all of you science students. So the idea is in this first container I have it's 8 ounces, okay, and I have 50% of it is oil. So 50% of the 8 ounces is oil. All right, in the second example I have 40% of, in this case it's 10 ounces. All right, so when we put it together we're going to have 18 ounces, aren't we? Okay, now it turns out that the oil in that container is 44.4%. All right, I'm going to show you how I get that in just a second. But the idea is you need to figure out the actual amount of oil in that mixture, the actual amount of oil in this mixture, and that is going to equal the total amount of oil in the final mixture. All right, so what we have is a percent of a number, a percent of a number, and a percent of a number. All right, and these first two need to add up to the last. So that's the example. So here we go. In oil, 50% of 8 ounces is how much oil? Well, 50% is half, so we're going to have 4 ounces of oil. We're going to add that to how much oil is represented here. 40% of 10, okay, multiply it out, 0.40 times 10, so that's also going to be 4 ounces. Okay, notice it's a larger container, but a less percentage of oil. So we got 4 ounces of oil plus another 4 ounces of oil. Well, obviously that's going to equal 8 ounces of oil. all right? But it's 8 ounces out of 18. So to find the unit cost, and I know I already did that, but it's going to be, it's going to be 8 divided by 18, okay, which will give us the amount of the percent of oil, okay? When you divide it out, you're going to get 0.444444 and so on, okay? So here we go, back to our original idea. It's the amount of substance in the first container plus the amount in the second equals the total amount in the mixture amount. All right. Now these mixture problems could be, you'll see some things like percent of peanuts in a nut mixture, maybe percent of sand in some sort of rock and gravel type of situation. It might be alcohol in water, it might be oil in water, or another kind of substance in water, maybe fruit juices. So those are the kinds of problems we're going to have you try, and you'll see these a lot on standardized tests. So here we go. Let's try 2 examples of these types of fluid mixtures. Number 3. How many quarts of a 75% saline solution, that's salt, must be mixed with 8 quarts of pure water to make a 35% solution? All right, let's give that a try. Pause the video and come on back. I'll show you how to do it. All right, what we're going to do is first try adding up the amount of salt. So the amount of actual salt in the first container plus the salt in the second container should equal the total salt in the mixture, right? So let's give that a try and see what happens. So how many quarts of a 75% saline solution? So it's 75% of X. Okay, we don't know the actual quarts in our solution there. Now we're going to add that to 8 quarts of pure water. Now how much salt is in pure water? That's 0% of 8 quarts. All right, now that's going to be kind of a problem, but let me keep going with this and I'll show you something. We want to end up with 35% solution. All right, so we're going to end up with 35% of, we're going to have X plus 8, right? All right, now do you see a problem? Yes, the problem is that this 0% of 8 disappears. You can't have 0% of anything, all right? So to look at it according to amount of salt actually is not going to work. Let's think about it now in terms of water. So how much actual water are we talking about? So let's rethink this in terms of water. And now you notice that if it's 75% saline solution, 75% salt, then we're going to have 25% water in that first container. Now it's pure water in the second container, so that's 100%. And now instead of 35% salt in the mixture, we have 65% water. Okay, we have to kind of think backwards. Now we should be able to work with this if we use X to represent the quarts in the first container. Notice the total mixture is X plus 8 quarts. All right, so we have to kind of think a little bit, and now let's go ahead and work on it with algebraic steps. Now we have to change our percentages into decimals, so 25% of X is 0.25X, 100% of 8 is still 8, and 65% of X plus 8 means now we have to do the distributive property. Now let's go ahead and get the x's on one side, so I'm going to subtract 0.25x here and here, which makes it gone on the left side. Let's go ahead and subtract 5.2 on this side and on this side. Okay, combining a couple of algebra steps. I hope that you're okay with that. Now let's see what we've got. So we have 2.8 equals 0.40x, or we could say 0.4x and drop the 0. Of course, our last step is to divide that number out. And so our answer is 2.8 divided by 0.4 or 0.40, and that's going to be 7 quarts. All right, how'd you do? All right, you had to think about it first in terms of salt, and then we had to switch it to water because of this pure water that we've added. Okay, we had to just kind of do it in an opposite direction there. All right, now I want you to try the next problem. Number 4, how much of brand A fruit punch, which is 40% fruit juice, must be mixed with 9 gallons of brand B fruit punch, 20% fruit juice, if we want to create a mixture containing 28% fruit juice? All right, set it up and come on back, I'll show you how. All right, I hope you gave that a try. Now let's see how we set this up. Now the first container we'll call brand A, and it says how much of brand A. So the amount is unknown, but we know it's 40% fruit juice. So 40% of X. Okay? Now keep in mind that means 40% juice, 60% water. These are pretty typically mixed with water solutions. All right? That's brand A. Brand B is 9 gallons of brand B, but it's 20% fruit juice. So the amount of actual juice is 20% of 9 gallons. All right? So we've got the amount of fruit juice in brand A plus the amount of fruit juice in brand B equals the total amount of fruit juice in the mixture. Now what do we know about that? Well, it's 28% of, now how many gallons are in the mixture? Well, we have an unknown amount in brand A and we have 9 gallons in brand B, so it's got to be of X plus 9. And believe it or not, we're still going to be able to work with that. Okay? Now let's convert our decimals or our percents into decimals and keep going. Now we have 0.40x plus 1.8 because that's 0.2 times 9 equals, now this is 28% of x plus 9, so that's our distributive property. 0.28x plus, what is 0.28 times 9? Yep, it should be about 2.52. Or even exactly 2.52. So, performing some steps in algebra here, we're going to subtract 0.28x from both sides, and we're going to subtract 1.8 from both sides. All right, so then our x term will be on the left, and our constant term will be on the right. At this point, we have 0.12x equals 0.72. Solving for x, of course, in our final step means we're going to divide both sides by 0.12. Now you can probably do that in your head. If you ignore the decimal point for now, notice these are both in hundredths. It's like saying 72 divided by 12, and that should be 6. So x equals 6 gallons. All right? 6 gallons of brand A would make that happen. All right. Thanks a lot for watching this video, and I'm going to give you 2 more to try in problem set 2. Thanks for watching.